Hello. Okay, so I had a nice story in the beginning, but it's kind of irrelevant now because I wanted to say that I had my first presentation here in 2012, and I wanted to say that it's the same place, but it's the same building, but not exactly the same room. But I just went there like automatically, and it turned out that it's not the same room. People were looking at me like, who is this guy? Anyway, in 2012, I had a talk about Data Mapper 2. And so many things changed. So today I will talk about ROM-4, which is coming. And my name is Piotr Solnica. I'm a software developer from Kraków. And I work for an Australian company called IceLab. We're a Ruby consultancy and a design consultancy as well. And we're kind of unique because we stopped using Rails, which is pretty cool. We started using our own stack that we built using GrillRB and ROM-RB projects. So today we'll talk about ROM-RB only. And it's kind of here already, version 4.0, sort of, because yesterday somehow I managed to release 4.0 beta 1. So you can install it and try it out, which I encourage you to do. And today I will talk a little bit about what is ROM in general, very briefly, and why it exists, why it was created, and then I will focus on 4.0 and why it's such a big release and why it's so important. It's the best release we've ever had. Anyway, ROM is an open source persistence and mapping toolkit for Ruby, built for speed and simplicity. It's database agnostic, it's flexible, it's extendable, it's fast, and it's simple, like for real. And since it's Ruby, you might be thinking that it's some kind of a crazy object relational mapper. Since it's Ruby, we're using objects, so if we are working with an SQL database, we probably use an object relational mapper. But ROM is not really an ORM. I mean, we have the same letters in the name, but the order is different. That's significant. Seriously though, there's some typical ORM crap that we really don't have. The first thing is that we do not have mutable objects. Like, this concept doesn't exist in ROM. There's no idea of instantiating an object into memory, changing it, and saving it back to the database. We just don't have it. We also don't have a very complex association model. We do have associations, and they are complicated because associations are just complicated. But we try to keep them as simple as possible. We also don't have leaky abstractions. This is very common for ORMs. In ROM, like everything that is public API, this is a first-class concept. If you're using relations and you use queries, this is a first-class idea. There are no leaky abstractions there. We don't have things like find by SQL, for example, as a workaround. There are some active record specific things that are really crappy that we don't have. Like, we don't have tight coupling with the database schema. We don't have callbacks, like no callbacks at all. And we also try to keep the API as narrow as possible. I mean, the functionality scope of ROM is pretty big, and we do have a lot of different types of objects with a bunch of methods, obviously, but we try to focus on APIs that are as narrow as possible. So ROM is not really an object relational mapper, and I could actually explain it to you more, but I really want to focus on 4.0, so you can check out my other talks where I talk about it a bit more. Really quickly, why does it even exist? You might be wondering, okay, like we have, I don't know, like at least 12 years of history where we've been building ORMs, using ORMs, and we have a lot of pretty advanced, pretty mature ORMs. Obviously, Active Record is the most popular one from Rails. So why even bother creating something new? So ROM was created as a true alternative to Active Record. And I say true alternative because every other library in Ruby which has anything to do with a database, some database, implements Active Record patterns. So even SQL, probably the most popular alternative to Active Record, is still Active Record. So even Data Mapper, as you may know, implements active record pattern. So that was a bit unfortunate because we spent so many years using Ruby to build all kinds of applications, all kinds of systems, and we only use active record. And that's just not enough. So ROM was created to provide a way to separate persistence concerns from application, kind of domain application layer. Originally, I mentioned before that in 2012, I was here talking about data mapper too. So originally, we thought that we're going to implement data mapper pattern, like as an alternative to active record. It felt very natural, like it's an object-oriented language, so we're going to use a different ORM pattern. Luckily, at least for me, we ditched this idea and built something that is not a classical data mapper implementation. So that was briefly about what it is and why it was created, but what's the deal with version 4.0? So ROM has an interesting history because before it was created, we spent roughly 2 years, even more than 2 years, trying to implement data mapper 2, right? So we spent a lot of time building all kinds of solutions, experimenting a lot, and then ROM was rebuilt from scratch in late 2014, just completely from scratch, on top of SQL, the library, and using different approach to solving problems that are common in ORMs, but in a completely different way. And at that point, we kind of knew what we want to have. So we didn't start with some high-level fancy DSLs. We started with some very basic, I could even say low-level components. So brief history lesson about versions in ROM. In January 2016, which is just a year and a half ago, we released ROM 1.0. And it was a huge milestone, but it was just the core API, right? With 1.0, we released stable core API, stable adapter API, which allowed people to build adapters, to extend existing adapters and build new adapters based on stable APIs. That was huge because getting adapter API right was really difficult. In data mapper, we had adapter API, but it was not so great because it didn't allow you to implement adapters for various databases because there was something specific to SQL, and that was just confusing. And coming up with something truly abstract was just, practically speaking, impossible, or at least not worth the effort. So it was really important, and with ROM 1.0, we were sure that, okay, that's it, like this can be the foundation for everything else. Now, at that point, people already started to use ROM in production, so that was interesting because it didn't have a lot of useful features. And the result of this release was a bit interesting because a lot of people were confused. Like, where are the docs? Like, this is too hard, why even bother? I don't get it. A lot of reactions like that. And that was fine. 6 months later, we released 2.0. That was even bigger release. The core API was extended with the idea of relation schemas, which allow you to define attributes for your relations with names and types and meta information. We added the first version of association model, and we added it to SQL adapter only. And we also added support for create, update, and delete commands to repositories, which was badly missing. So that was a big release, and the result was a bit better. Like, some people actually liked it, and more people started using it. But still, a lot of people ended up being confused. Like, okay, so I can use commands, but what's the deal with schemas? Like, okay, I have advanced projection API. Why do I even need projection API? So still a lot of confusion. Documentation was still not really there, but it was fine. We kept going. And 6 months later, which was actually this year in January 2017, we released 3.0. And that was even bigger. We really pushed forward the idea of schema API. It became like the first class API in ROM. It became available to all adapters, which was really huge. We introduced the idea of dynamic schemas, which means that even when you use advanced queries to project data or literally however you want, we still maintain all the information about the resulting data structures, which is really important. Now, SQL Adapter was extended with very powerful query API. I would even say it's the most advanced Ruby API for SQL queries. And we added an early version of something that we call auto mapping, which means that we can map any kind of data coming from a database into struct objects, which are just simpler to work with than plain hashes. And we also introduced change sets, which was like a completely new idea. And again, big release, a lot of important stuff. And the results, people still a bit confused. Some people, appreciated new features, but still a lot of reactions were like, well, okay, this is cool, but I don't know, why do I want to use change sets now? And what's the deal with, repositories giving some features that I cannot use in other places? So we just kept going, improving core APIs, adding more advanced features, and listening to feedback as well. And eventually, we've built so many things into ROM that we realized that it's time to actually put things together and just push it really forward in terms of making it simpler to use. So this brings us to ROM 4, also known as serious business. So with ROM 4.0, we had this big challenge, which for me personally, at least, that was one of my personal dreams. It even goes back to Data Mapper 2 because I wanted to have a library that is much more advanced than Active Record, much more flexible, a library that I can use to work with different databases, and yet have it simple to use somehow. I didn't know how. It took me 7 years, but it's possible. So with 4.0, I wanted to make ROM easy to use, even comparable with Active Record when it comes to the ease of use. So if we want to compare this, we kind of need to take a look at Active Record again. I know that if you're using Ruby, you use Active Record, that's a given. So what's so awesome about Active Record? I don't like Active Record. Both pattern and the library, I just don't like it. But it doesn't change the fact that I can really appreciate some aspects of Active Record. So the first thing is that there's no boilerplate. And initially, I kind of hated the fact that these models are empty. But then when I worked with a library that forces me to define all this stuff, I realized that, there are some situations where I would really like some automation, some magic, right? And this is the true power of Rails in general, not just Active Record, that there are these strong conventions that allow you to move so fast. And it's especially important when you're starting a new project. You need to move fast. Now, there are other things nice about Active Record that are just pretty obvious, but it's important to just realize this, that things that are kind of complex, like persisting data, is really complex, but with Active Record, it's one line of code. That's awesome, really. Even database queries, they could be really difficult. There are various libraries, maybe even in Ruby, definitely in other languages, where in order to execute a query, you need to start a session, sometimes configure it, create criteria object, pass it to session, execute session, find out if there's an error. This kind of stuff exists in other libraries. In Active Record, is one line of code. That's really great. Same with making changes to your data. I actually specifically did not use an example of instantiating a user, mutating it, and saving it back to the database because it's awful. But Active Record does provide various ways of making changes to your data in a very simple way, just one line of code, again. So this is really about the ease of use. And again, it's so important when you start a new project, especially if it's something that is new to you, like maybe you're building an application that has a domain that you see for the first time in your life, and you really need to learn about it, and it's a process, it takes time. So if you can get started quickly, if you can build features, create some initial user interface, it's just beneficial for both you and your clients, so it's worth the effort to have this kind of ease of use. Now, back to ROM, this is a real challenge for ROM, because ROM is a different library. there are a bunch of, actually a lot of reasons why it was a challenge for ROM, but here are like the most important ones. So the first one is that we have dynamic queries. It means that, well, Active Record has dynamic queries as well, but in our world, dynamic queries means that you can use a query API to load any kind of data, and we want to map it to objects that are easy to use, which in our case, these are just structs. We have our own implementation of structs, but you can also use your own struct implementation if that's what you want. And it's also important to realize that they are not connected to the database. This means that you cannot instantiate a user and then ask the user for its, I don't know, tasks, and then it's going to hit the database and get the task. Like, it's not possible because structs are not connected to the database. That's a huge difference between the two libraries, or in general, the two approaches. So this means that, practically speaking, we cannot lazy load associations. You need to say that I want a user with tasks, and then you're going to get it. You cannot do it in 2 steps. So these are like the most important reasons why it was a big challenge, but this is fine. We made it. With magic, of course. Every time you have a really big challenge in Ruby, you're going to solve it with magic, so that's good, because it's possible. And in ROM, it really boils down to 2 things, relations and structs. So relations in ROM, I personally described it as like the real heart of ROM. This is the most important component to understand. And in ROM, relations are basically objects that you use to talk to your database. They are database specific, so if you're using ROM SQL, you're going to have SQL specific relations. If you use ROM Mongo, you're going to have Mongo specific relations. If you use, I don't know, a simple adapter for YAML or Git, or I think we even have XML for some reason, then you're going to have relations specific to these adapters, and they have different query APIs. But it's important to understand that these objects are responsible for talking to your database. And the data in ROM are represented as struct objects. We prefer structs over hashes because they have attribute readers. That's seriously the only reason. Well, and nice equality operators. That's also really, really interesting, important to have. So it's kind of similar like an active record. A relation is a class. If you remember previous example of a user model, you probably noticed that there's one extra line of code here. So relations have schemas, and they define all the attributes that a relation has. And since we like magic in Ruby, we have schema inference. So we say schema infer true, and it's going to inspect your database schema and get all the attributes with all the meta information like types and index names and all this stuff. And it's going to be established for you. So that's just automation through magic. And it's cool because you don't have to specify it manually. But it is an extra line of code which we decided to always have because it's important to just know that there is a schema. So with this, check, no boilerplate. Like, you create a table, you add columns, you have a relation with everything you need in order to start using it. So same as with Active Record. Now, what about creating data, like persisting data? It's also very similar like with Active Record. We can just create data with relations, and that's it. I'm cheating right now. This method doesn't exist yet, but I swear I will add it tomorrow. It's very simple. Anyway, eventually, check persistence. So simple. You can just create data. No, seriously, like, it's going to be there. What about queries? Almost identical. You just use query DSL, and you get back data. The only difference is that we have this special method called one, which is just much more explicit than first, because one means I expect to have one result. There's also one with exclamation mark, which will actually raise an error if there's more than one result, which is just more explicit. And it actually saved me a few times from bugs, so that's cool. So queries, so simple, check. Same as with Active Record. What about changing data? So in ROM, it's a bit more sophisticated. We introduced the idea of change sets. Change sets are actually, in 4.0, it's going to be a separate gem, separated from ROM itself, but integrated with ROM through a plugin. So you're going to have access to change sets through Relation API. So here it's kind of similar like with Active Record, still one line of code. You find some stuff, find some data, users where name equals Jane. Then you ask for a change set to update it, and you commit it, and you're done. So again, very, very simple. So check, making changes, very simple. But there are a couple of really important differences between how it works in ROM and what it means in ROM. So the first one is, if you get data in its canonical form, which is defined by your database, like if you invert a schema from your database, you will get all the attributes with all their types the way it's defined in your database. But you can project data however you want. Here's a very trivial example. You just select a name, right? So the difference is that if you select specific attributes, ROM will give you back a struct with these specific attributes, and it's going to be represented by actually a separate struct object. It looks like the same class, but it's actually a different class. So there's a big difference between how it works in Active Record, where you can use find by SQL, and it's going to just execute this query, which can be an arbitrary query returning arbitrary data, and it's going to put it into attributes hash. So you have this weird situation where you can have, and I've seen this personally, you have, let's say, a user model which loads data that is just completely different from what user actually is, but somebody needed a fast query with very specific data back. So that doesn't feel like a first-class concept. So in ROM, it is a first-class concept that you can use any kind of a query, and we're going to map results to easy-to-use structs. If you take a look at these models that we generate, these struct classes, and take a look at their schemas and keys, you will see that the first one has both ID and name, and the second one just has a name. Now, it's typical in a language like Ruby that we want to encapsulate things using methods and objects, right? So we want our own methods. So automatically generated structs or empty Active Record models, it's just not enough. We always want to have our own methods. So the way it works in Active Record is pretty obvious. You have your own methods. That's it. But in ROM, it was a bit more challenging, but we made it. We implemented a feature called custom struct namespace, which allows you to configure your relation with a specific struct namespace. Let's call it entities for whatever reason. So you just do this, and then you can, let's say, define module entities with user struct and just add your own methods. And notice that this is also convention over configuration. So very similar idea as with Active Record. So we have a users relation, and then we define a class called user, so we're going to map it to user. Now with ROM, you can actually alias relations even at runtime. So if you do like users as admins and have a class called admin, then we will use this class instead of a user. So it's pretty flexible. And of course, you just have these methods available. So if you load a user, you'll have first name and last name methods that are your methods. Now, the interesting part is that even if you project data differently, you still have access to these methods. So this is like the base class that we use to create other classes. So you can create like an abstract implementation and then just project data however you want, and you still have access to your own methods. Now, what about associations? In ROM, when it comes to structs, associations are just nothing special. It's just an attribute, right? There's no difference between name, email, age, and a list of tasks loaded from an association. It's just a struct with attributes. So in ROM, you can define associations in a similar way as with Active Record. So you just say associations has many tasks, and that's it. You can then load users with tasks, and you will get a user entity with tasks. That's it. Now, important part here is that if you define methods in your structs that rely on some attributes, you can obviously do that, and it's going to work. But there's one caveat, like what? Oh, sorry. Yeah, it's the one. That's the one. There's one caveat, like what if you loaded some data and forgot to load some attributes or some association, and then tried to use a method that actually needs some attribute or some association? So that was a big challenge, actually. I know it sounds funny, but it was a big challenge. Like, how do we do that? Like, what do we do in this situation? So we just raised an error. which sounds like a simple solution, which it is, but it took a while to understand this for us. So if you try to use a method that refers to an attribute that wasn't loaded, you're going to get an error saying like, whoa, maybe you didn't load this attribute. And again, this is just for convenience, right? So we have this highly dynamic behavior and an active record-like feeling so that you can just use it in a simpler way. So what does it mean really when it comes to ROM itself? So even though we have a lot of advanced features, we were still able to maintain the dynamic query interface, which again means just projecting data however you want using a very powerful query interface. And it's still maintained, like there are no restrictions. You can still define your own classes with your own methods. You can use associations or not, and things just work. You can add your own methods, and you end up with structs that, technically speaking, are coupled to your database in the sense that you need ROM connected to the database to have them, but that's just a trade-off. Like if you want to move fast, it's a trade-off. You need to just say, okay, I'm going to live with that. Now, this is actually pretty awesome, and I will tell you why. First of all, you can use ROM, I'm not going to say in an active record mode because that would be too much, but you can use ROM very effectively and build an application pretty fast. You can move. Okay, you can move as fast as with active record, or almost as fast as with active record. You can provide your own methods, you can provide your own structs, and you get this active record-like convenience, which is really great. But there's one but, really important one. This is not enforced by the library. Like all these things that I showed you with magic and creating classes on the fly and defining attributes automatically, all this stuff is convenient, it's nice, it's cool, it feels really good, I can promise you that. But it's not enforced by the library. It's not the way of using ROM, it's a way of using ROM. And it's really up to you how you want to approach building your application when you use ROM. So what it means in practice is that at any point in time, you can say, I'm done with the magic, right? Like, I reached a point where it's just too much. Like, I ended up with, I don't know, this big user model, which I'm sure you know from Active Record world, or just really confusing mixture of methods that you can't really understand why they even exist in this place. And, you know, this takes time to like establish different models based on like your knowledge about the domain and your experience building a given application. Right, I went too fast. However, yeah, this requires time, right? So you can start simple, you can start relying on magic and relying on a lot of automation. And over time, you're going to just see that, okay, I have these concepts, and I now know how to name them, which is actually pretty tricky. And you can start breaking things down into smaller pieces. Like you may realize, okay, I actually have 3 ideas of a product. Maybe you have a shipped product and canceled product or whatever, or an admin and a moderator and a guest instead of just a user. And you can start to see this and just start to refactor, and ROM will help you because it's a process that ROM fully supports, like right from the start. It's designed to just help you along the way. So you're just not stuck with the magic, you're not stuck with automation, you're not stuck with convention over configuration, but you still have it so that it can assist you in the early days of a project. So I want to end with show-off, small show-off. I'll show you just quickly 10 things that you can do with ROM that Active Record cannot do. This is upside down on purpose. So first one, probably the most obvious one, you can use it with non-SQL databases. It's true that ROM SQL is the most advanced, the most mature adapter used in ROM, just because SQL, you know, it's the most popular type of a database. I know that MongoDB is web scale, but it didn't help. So when you use ROM with a different database, a non-SQL database, you use it in a very similar way. Here you have an example of a relation that is configured for a Mongo database. We define schema explicitly because, in Mongo there are no schemas, so, or at least it didn't have schemas when I last checked. And it works in a very similar way. There are differences when it comes to query API because we want to have query APIs that are dedicated for a given database. You can't really have an abstract query DSL for every database. They are just too different. So we just ditched this idea of a common abstract query API. We have different APIs for different databases, and it works very well. Number two, you can define cross-database associations, which is really cool. This is a new feature in ROM 4.0. It requires a little bit of extra code. So in ROM SQL, if you define associations within the same database, we can generate things for you, just automate that. If you're defining associations between different databases, you just need to define the logic that is required to actually fetch the data. But it's still very, very simple and totally possible. And if you're wondering, like, who does that, I can promise you that people do that and need that, not for fun, but really, really need that. Number three, you can map to any model. As I mentioned, you can start with auto-structs, automatically created structs, you can start with magic, but at any point in time, you can define your own classes. And mapping to any model in ROM, it's a first-class feature that was implemented in ROM from the very start. So you can use a struct that inherits from your own MySuperModel library, or you can even don't use any library and define your own structs as simple objects that will just receive data as a hash. And you can just say users map to my user, and you're done. Number four, you can project data easily. I mentioned this many times in this talk. Data projection is really important in ROM because this is one of the tools that you can use to simplify your data structures. Databases have really powerful features that allow you to just project data into simpler form. And you can leverage that with ROM. So, for instance, if you're using JSON-B in Postgres, you will really like what we have for you. Like, let's say we have a meta JSON field, and you can say meta, get text, comment count, cast to integer, alias as comments. And you're going to get back a nice struct with nice attribute readers, and it just works. 5, easily construct complex conditions. I might be biased, so maybe don't listen to me, but I really think that we have the best query DSL in Ruby. Although I have to admit that we do use SQL, and like 80% it's SQL, 20% it's ROM, but the additions that we have are pretty significant, especially the schema API with attributes, with database-specific extensions like this JSON-B that I showed you. You can write your own extensions if you find yourself using some complex method calls and you want to encapsulate that into a single method call. You can do it. It's a public API. You can extend it. So it's pretty awesome. Number 6, easily use SQL functions. This is kind of related. You can use SQL functions like your first name and last name. You want to concatenate that and rename as a full name. This str, it's a type definition. Looks cool, probably, at least for me. It's just a method call, double colon. It's a method call in Ruby. So we use it to specify the type of the return value, which allows us to carry all the information about the attribute, which is the result of this function, which is a full name, which is a string, which is a concatenation of first name and last name. So that's pretty cool because you can use a lot of functions, and it's pretty helpful. Number 7, you can create nested data without special model configuration. With Active Record, you have this thing called nested attributes for. And if I remember correctly, the guy who wrote it actually admitted that he regrets that he wrote it. I tried to use this feature. It broke all the time. We have partial support for it. You can basically just use associations to combine data the way you want, and then you can just say create, pass in nested data structure, and it's going to insert everything. This is now limited to creating data. It doesn't work with update and delete, but I do have an idea how to do it with update and delete, so it's going to be added soon. Number 8, use it with legacy schemas without yelling at your screen too much. I'm not going to say that support for legacy schemas is a first-class feature in ROM. It's more like a side effect of the design of the library, that you can do certain things that help you when you need to work with a really awful legacy schema. So for instance, if you have some database with some really terrible table names and really terrible column names, you can just rename them, and things will work pretty nicely. Number 9, define custom data mappers. I know that these days it's not really visible when you use ROM, but we actually use mappers all the time. It's just magic. It's under the hood, it's generated automatically for you, but we do have mappers. It's a first-class concept in ROM. It exists since day one, and you still can define your own mappers. And it was pretty interesting for me because at some point I thought that we don't even need this API, like we automated that, we don't need custom mappers. And then people started telling me how they use mappers, and I was just blown away. Like, I didn't think that there are use cases like this. So it's pretty cool. We still have this API because of this. You can define your own mappers. Mappers are actually completely abstract in ROM. They can be procs, if that's what you want. We do have ROM mapper gem, which just integrates with gem, and it just adds a little bit of convenience. And then using mappers means just saying map with and the name of your mapper, and that's it. And you can literally do whatever you want inside this call method. Last but not least, we have change sets, and this is, if you use Elixir, you're probably familiar with this. It's pretty similar in ROM. We have change sets that are, in Ruby at least, quite unique. And change sets, probably the only reason why you want to use change sets, well, 2 reasons. One is data transformation. You can transform data that is just not compatible with the structure of your database to a structure that is compatible. And they also have some additional APIs for associating data. So that's the last point, and that's pretty much it. ROM-4 beta is out. Please check it out. It's very early, so you need to be brave. If you're not brave enough, it's fine, of course. Just wait for the final version. I just wanted to mention that we will have documentation written before 4.0. I can promise you that. It's really important to get this done. So we probably need still like a month and a half, 2 months, and it's going to be awesome. So please try it out. If you tried it out and something didn't work, let me know. If you tried it out and it was awesome, please also let me know. And we're more than welcome to see contributions. We're a very welcoming community, so if you would like to see some interesting Ruby code, check it out as well. So, thank you. That's all I had today. It was a pleasure to be here. I'm not sure if we have time for questions. Do we have time for questions? Yes. Yes, great. Okay.
Okay, I have 2 questions, but for the one with documentation, you already answered. So the second is, what about performance? Did you do any comparison about? Is it any way better than Active Record in terms of performance?
Yeah, it's the fastest library in Ruby. No, it's really hard to benchmark this type of libraries because it really depends on the context. We have very basic benchmarks, and it's faster in every benchmark. It's faster than Active Record, both for reading and writing data. There are some, in the existing stable version 3.0, there are some bottlenecks, but they got fixed. So right now, especially when it comes to loading larger data sets, like thousands of objects, it's significantly faster than Active Record. And it's mostly because instantiating structs is just faster than instantiating Active Record instances. And SQL is faster than Active Record, and we use it as the underlying engine. So I'm not going to say it's definitely faster like all the time, but there are a lot of cases where when it's faster, and we will make it even faster.
So one more question. I can't imagine that it would be affordable to rewrite a big project, but what's your recommendation about usage? Is it the best to use in microservices or where?
Oh.
What type of applications it makes a lot of sense to actually use this ROM
Um,
structure?
if you have an existing application with Active Record, regardless of the library, and it works, right? But if you have some cases when, I don't know, something is just too complex because of maybe queries or just in general when it comes to the business logic and you just want to break things down, you could start using ROM like separately, but ROM with Rails, it's a weird mixture. It's gonna break with code reloading. It might be affected by monkey patches. So, yeah. You really need to have a good reason to try this. It's not like I discourage you, to use ROM with Rails, but I tried to use ROM with Rails and I had some issues. Maybe if you're extracting a separate service, that would be a good opportunity. Like, just not use Rails there, use something else, and use ROM. It's probably a really good idea to try out ROM when you have things like heavy data processing in the backend, like data synchronization, whenever you need to like get data from different places and maybe merge it together and then, I don't know, persist in your own database. This kind of stuff, ROM will be very useful because we have a lot of tools for this type of a job. Yeah.
Do we have any other questions?
You mentioned things that ROM has unique features that Active Record doesn't. Is there any Active Record features that ROM doesn't have, or would it require, I don't know, copious amounts of time to implement? Are you aware of such features?
Yeah, definitely. I mean, Active Record has like, I don't know, 14, 15 years of history. There are definitely a lot of features that ROM doesn't have. I don't know, I'm trying to think of anything.
What is the biggest?
Or maybe
Callbacks.
maybe I'll rephrase.
It has callbacks.
Oh, cool.
No, we have transactions.
Maybe I'll rephrase the question. What would you implement in ROM from Active Record, for example? What
Nothing, probably. Like, no, seriously, like
You've taken all the good parts already.
Yeah, like the stuff I talked about today with this just conventional usage and the magic, lack of boilerplate. This is the kind of stuff that I really liked with Active Record, and I wanted to have it in ROM, and now I have it. So there's probably nothing else. Well, I mean, there are some more low-level things like we don't support prepared statements. We want to support prepared statements. This kind of stuff, but more low-level stuff. I don't have anything. I really don't know. I would have to like go through Active Record API and see.
Okay, thank you.
Okay, thank you for the questions.
Yeah, we're out of time. Thank you very much, Piotr.
Thanks.
We're on close. So.